Hey everyone, so in this last video we're going to be talking about correlation. So a major goal of many statistical studies is to determine whether one factor causes another. We'll discuss how statistics can be used to search for correlations that might suggest cause and effect relationships. Right, so a correlation exists between two variables when higher values of one variable consistently go with higher or lower values of another variable. So, for example, there's a correlation between the following: height and weight for people. So, as height increases, weight increases. All right, so there's a correlation there. The demand for apples and the price of apples. So, as the price increases, what happens to demand? So, if apples were $100 per apple, would you still go get them? Probably not, right? So, demand decreases. All right, practice time and skill. So hopefully you are learning this about math by now, but more practice means better skill. All right, the more you practice, the better you get at something. So establishing a correlation between two variables does not mean that a change in one variable causes a change in the other. All right, let's look at scatter plots. A scatter plot is just a way to put data that might not actually go into a line. All right, so for example, we have a table of biggest budget movies through 2012. Right? We have the production cost and the US gross receipts, both in millions of dollars. All right, so if we put all of those in a plot, you can see it doesn't make a line or anything like that, but each of these movies are represented. So, for example, Prince Caspian right here was at $225 million production cost. So that was the x-axis. And it made $142 million. That was the y-axis. And you can put a dot right there. Right? For each of these movies, they're just a dot on this grid now. While in this case, it might look like these are just kind of random dots, we can actually find correlations on scatter plots. So before we start looking at some more scatter plots, types of correlation. So if we look at the scatter plot for movies, the dots seem to be scattered with no apparent pattern. There appears to be little or no correlation between the amount of money spent and the amount of money it earned. Now, if we look at this example, so this is a scatter plot which shows the weight in carats and retail prices of 23 different diamonds. In this case, the dots clearly show that there is an upward trend, right? They're moving upwards, so larger diamonds tend to just cost more, which makes sense, right? So because the prices tend to increase as the weights increase, they're both increasing, we call this a positive correlation. Okay, both variables are increasing, or both variables are decreasing together. All right, what if we look at the life expectancy and infant mortality in 16 countries? So this time, these also kind of form a very, very loose line. You can tell it's, in general, going downwards. So this time, it is a negative correlation. All right, the two variables go in opposite directions. So one's increasing while these others decreasing. In this case, the life expectancy increases as the infant mortality rate decreases. All right? So countries with higher life expectancy tend to have lower infant mortality. All right, last thing, the strength of a correlation. So the more closely two variables follow a general trend, the stronger the correlation, which can still either be positive or negative. In a perfect correlation, all the data points lie on a straight line. So let's look at these two. For the first one, it's going up, and all of these are pretty tightly packed together, right? So since these are pretty tightly packed together, we say that this is a strong positive, because remember, it's going upward, so positive correlation. All right, let's look at the second one. So the second one, again, seems to be increasing, but the dots are a lot more scattered this time. It's a lot more spread out. They're not as close to the line. So in this case, we say it's a weak positive correlation. So it's strong if the dots are really closely packed together. It's weak if the dots are spread apart. All right, and that is it for correlation right now. So that is the third and final video for these notes. So bye guys.